This conference will now be recorded.
So initially, if your Python will take random weights there. Definitely, most of the cases, feed forward may not be gives best. Obviously, it should work. It will work, but it won't give the best result. So to improve the performance, yes, you need to put into your back propagation method. Then only it will work. So people hope you had a blast on Diwali and you enjoyed for 2 days, 3 days. So no time to rework on the code which I given. Hope I forwarded that code right. Back propagation method. Next time try it. Next time try it and see the result, how things are working or not working. Check on it. Why? Because the thing, your deep learning is going to be on those basis on everything. Okay, deep learning is completely based on those only. So you have learned till now what? Simple neural network. So when your simple neural network will work out, when you work on simple neural network, to say like what are the things involved in that simple neural network? Input layer. That is your X. Okay, that means your input variables, strictly specific input variables, and one hidden layer. Yes, and finally your output layer will be there. Obviously, output layer will be there. So this is what if you put up in a loop system, you have seen. If you put up into a package, then it will be other thing. It will be more easier, of course. Why? Because the package will work completely feed forward work and your back propagation method. Both it will take care at one shot. Okay, no need to work on that loop. But that loop is to make you understand how the practically working at the back end. Okay, today we'll talk about how this will work on the loop as well. So our package as well. Okay. So for that purpose, you has to install Keras in your system. You has to install the Keras. So it will be a, you can install from the Google. So just click on installation on Keras. So you will find some page installation of Keras. Okay. So tutorial points it is mentioned. So you can grow with any system. To say any what do you say this one? Wherever you find this one mentioned, you can go with the things. For the right one actually. Yeah, you can go by this method. See, create a new Conda environment. This one. So where you should create this one? You are this one. Hope you know it. You'll have this one, no? Anaconda prompt. Yeah, when this gets opened, you people are using Anaconda only, no? So yes, you need to write this statement here as what? Conda create dash dash name Python CPU. So Python CPU is I am creating an environment in the Anaconda. Okay, what that environment I'll tell you. Now when you open Anaconda actually, so before actually now we are trying to learn what actually Keras. So most of the people when Keras is not launched, TensorFlow is the package that we actually people are worked out. So later that TensorFlow has some drawbacks people have seen. and they updated with the Keras. So this Keras also will coming from the TensorFlow by the backend only. So when you're running this Keras, no need to create a specific environment for TensorFlow. By default, it will works. So and also so easy to write the code as well. This is the advantage of working with Keras. Okay, let me show those things first. What is environment? If I make you understand, then it will be easy to make you this one. So you have seen this kind of thing in your systems as well, right? So if you see here always applications on base root. Okay, so this is the only thing it will be there in your system till now. But when I created this environment in Anaconda prompt, na, okay, so here there will be another environment be added in the drop down list. If you see here, why it was taking so much time? Normally it won't take this much time. It will directly display. We go here. Yeah. So whatever the name, if I give here Python CPU, okay, the same name I also give it. Okay, and then what? Activate Python CPU. You need to activate it. Okay. So no need to install this spider. It is already with you. No need to working. You need to worry about. And I think that is the only thing. Just try out. You should work. It will create. If you want to deactivate, you can deactivate it. It will be removed. Yeah. If you see here, you could see right Python CPU. This is how I created an environment. So when you are working this deep learning, you have to select this one. Specifically, when you are working with Keras TensorFlow packages, you need to enable this one like this. When I enable it, actually my spider was actually 3.3.6 version. Now if you observe it, it will be updated with the 4.001 version. Some updated new latest version will be there. Okay, it is still it's updating. Yes. If you see here, yes, PowerPoint is 0.1. I mean, updated Spider is launched here. But in your case, I think both will be same. Okay, for the base channel, for Python CPU, both will be you will have the Spider version will be same. I guess so. Or else the latest one will be comes up. Okay, so you need to open your Spider from here, like this. You need to be open the Spider from here. Okay, we'll wait till it gets open. Not open still. Yes. Taking long time, na? Okay, and where is our data here? I think we have our data here. Okay, everything will be same the way how you feel, how you see in the previous cases. So what we will do, we will take our code which we have used in the previous example. Okay, and so not required. Right? Huh? Why should I take the same thing? We'll take some other one. So I have an example. Let me take. Yeah, this one. This is a data set contains of some mining rocks. People will work on mining things. Yeah. So here I have description. So this is the data set used by some government and Senesco. So to classify of their sonar signals. Okay. So it is explained about what actually why they have done this task. So finally they could see there are two types of rocks they found. Okay, two types of rocks. So and they want to identify that which one is what is it? This one. Check here. Your go-to-meeting page will be always makes me distant. Yes, we have two types of classifiers. One is rock and another one is something is there. Anything here? Yes, here only I think. Mines versus rocks. Yes. Okay. There is a difference to understand actually exactly rocks and the mines. Both looks almost same, but there will be some difference. So you are trying to identify which one is rocks, which one is going to mines. Understanding? So I mean, after doing several tests, and they will find that I mean, everything will have some features, right? That it is mine or rocks, they will have some shape or some quality of all the minerals what it contains. So you will have some information. So this is about those all information. Okay, the data is already standardized. Okay, that's why you have data like this. So we have here 209, 208 rows, and we have 61 columns. All right. And the final column target variable is what? M and R. So you need to identify. That means you are making your machine to be trained in a such a way that whenever I give a similar kind of features, okay, whenever I give a similar kind of features to my system should be able to identify that it is a actually rock or mining rock. Okay, that is what our system's responsibility. Okay, let's pull this information here first, and we'll try to classify it. Okay, so this one, let me save this one too. Yes, already there. Okay, let's copy and here. Okay, and let's write the same thing. This is going to be same. Let's give the here. So pd dot wheel underscore v. Okay, and here I'll give name. So sonar data csv. And let's save this file into your folder. And First give SNN. We have given SNN and give, let's give us 2. Oh, I need to run F9 here. So we have our data set with us, and yeah. So what I used to do actually, always I would separate my X, right? So df dot, I'll drop my code. That is what y variable. So y variable is the final last one. So how should I write? Yeah, y variable. I mean y variable name is y. If you see here, last one it is. So directly I'll give the name as y. And access equal to 1. So yes, now X contains shape of 208 rows, 60 columns. Okay. Similarly, y is equal to the same thing, df brackets y. Okay. So yes. So if you see here, my y is actually in what form? Textual data. I mean classified data. So I need to put into what? Numerical data. Why? Because you are trying to compare finally at the results with like it's a classification, right? So you cannot predict them as R and M directly. So you need to put into numbers. So which are the method that you use, you can use as per your choice. So what I'll do here is the best easiest way is, yeah, label encoding method. Label encoder for y. So from scikit-learn dot preprocessing, okay, import label encoder. All right, and I'll give this name as encoder. No, and this contains whatever the work like this. After doing up this one, what again encoder dot fit what values, your y values, right now. So that to be saved again in the same way. So encoder will transform, yeah, fit transform, yeah, directly I can write, yeah, I made use like this. Okay, whichever the method that you feel comfortable, you can write it. Now this one should work. Your y values will be converted here into like this 10000. Okay, so 100 rows are ones and 100 rows are zeros. So how it will be done? Alphabetical order. So we have M and R, right? So A, B, C, D, E, F, G, H, I, J, K, L, M. M comes first, so M becomes zeros, and later it will come R, na? So it will become 1. That is the order it will take. Alright. So your target variable is ready with you. So what's next? We need to work on the neural networks. So to understand that one, yeah. So how to write this one? You can write 2 ways. The way which I told in your previous one, like writing the loop method. Okay. Now if you check here, what is your y shape? 208, right? Okay, 208. And what is the x shape? 208 rows, 60 columns. Now let's understand how it is going to be happen. So 208 into 60 is your what? Input matrix, no? Okay. So what is your layer one? Tell me. How much should I take for layer one?
150.
One and a half times I said. So 150 is correct. 208 star 90 is correct. 100 times, because one time it's already 60, again half time, so that is 30. So 90 times is correct. Right now. And what is your y here? 208 8 into 1. So you can imagine the remaining things. What should be your weight? Weight 1. $60 by 90. Yeah. 60 goes 208 by this one. Okay. And on top of this, what you will do? You will apply your function. Okay. Similarly here, weight 2. So 90 by 1. Huh? Why is so fast in typing? Huh? Okay, good. What next? So what should be your y hat value? Same thing will become out, right? Y hat value will be like 208 1, and you need to work on any function. So anyway, definitely we are our target variable is what actually? Classification, right? Classification. So the target variable is classification. So yeah, what function can be applied here? Definitely sigmoid is going to be the best. So I don't mind what function you will apply on my layer 1. I'm not caring about it. But ultimately, when I'm coming to reach at the end, definitely sigmoid function only should be applied. Agree? Why? Because sigmoid will makes more nearest to your 0, 1. That is the key point that you need to understand. So you should be more clear that which function to be applied at what cases. Okay? If my value is, sorry, if my target variable is continuous, so which one is going to be the best? ReLU is there, softmax is there. Okay, like that, some functions are there in the deep learning libraries. So you can try it with anyone out of those. All right, now come back. So we are ready with your here matrix. So now you can work, as I say, you can work with the two types, the way which we discussed in the previous coding method, or else we will go with our this method. Today we'll learn this method. Okay. So here, if you check, my x is actually, will understand it's in pandas core fit. So when I'm trying to write Keras won't accept your x to be in pandas thread. So for that purpose, I need to put back into what is it? NumPy order, NumPy format. So how we are going to write? We can write multiple ways. I'll write it in the easiest way. Xn. So Xn is my new data set, and np dot c underscore brackets your actual x. So here I'm writing, yeah, that means when I'm using the np means what here? NumPy should be there. NumPy as np. All right. Now if we check this xn, so type data won't change, only the kind of format will be changed. NumPy. Clear? So now you are going to use this Excel as input for your Keras libraries. That is what. Pandas won't be worked out there. All right. Now we have to launch your libraries Keras. So how we are going to write this one? So from TensorFlow. See, these things are trying to show you. TensorFlow import Keras. All right. Let me run first this one. Sometimes some updated packages will be there. It may get disturbed for us. So I need to make it trial first before I go for the next line. Okay. I did not able to see is it working or not working. Still running. See here. So of course, I mean, when you open for the first time in your session, it will take some time. But when you close it, when you rerun it again, it won't take much time. Okay. So for the first time, definitely it will take some 1 minute of time or some seconds, 30-40 seconds of time. Still it is running. Let's let it make fish. Need to wait. The coding will be very easy, guys. Here. The thing is, what actually it is doing, that is what you need to learn. Okay. Yeah, it is done. Now another line. So there are many things are there. So what is required for me? I'm trying to pull up those. Keras and import layers. So you have to make sure that your spellings also should be correct. Okay, makes large errors. You cannot understand where the error is happening. Okay, it is also successful. So one thing, I imported Keras from Keras again I imported layers. We have down two things. Now here too, I need to write this total program into step by step. So first of all, I need to create your structure. The way how we are visually writing, and we are, we are imagining these things and we are converting into structure. No? This structure I need to frame it first. Later I will pass the data. Okay. So let's create the structure, how it is going to be happen. So I am giving the name as model. Give any name. Give as SNN or whatever. I give the name as model. So Keras dot, there will be sequential input. Sequential. So we are trying to put, yeah, we are trying to put, asking to give everything into a sequential order. So by default it will come with brackets. So I'm making enter here. I'm making again enter here. So here I'm opening a square brackets again. So I'm giving a gap between two these things. So I'm to write here the things here. So parenthesis square brackets. Use both. Okay. From here again, yeah, I need to start from here. Layers. So when I'm writing layers, it is going to help us. Dot dense. All right. So inside. So what is your first input matrix contains? What are number of columns? 60 columns. 60 is your input matrix. So write 60. Okay, comma, and what activation function that you are to put on layer 1. So I'm not going to create any W1 matrix here. These 3 steps will be taken by K by what? This layers line. This layers dot dense line will take care of everything. All right. So no need to sorry, no need to worry about the what weight values, how much to do, those all things. I'm doing only my input and what activation is required here. Activation. So this one I'm trying to take here value. Why? Because you have seen when I'm writing random weights values, yeah, I could see some negative values. I wantedly I created some negative values, of course. But when I'm trying to convert into those, we applied some method and we worked on those things. So similarly here also we are trying to uh, take the instead of negative values, we are trying to take positive values. Okay, so I don't want to make negative values as input for the next function. So what really will do? Really will take only positive values. And I say if you recall, if I pass -10, it will take as 0. If I pass a 10, it will take as 10. That is the advantage here. And the name, so I will give the name as what here? It is layer 1. So this enter line, it's constructing your first layer. That means till here. Understood? Till here it is constructed. All right. Now next I will copy paste as it is here. All right. Now what will be the next? I mean, once it is constructed, so what will be my next input here? What should be the number of columns to be given here? Because it contains now 90 columns created in the layer, so your input should be 90 here. And once it is created, so what function again you are applying? So here I'm mentioning as y hat, right now. So to get that y hat, what function that you are applying, that function name. So I will give here as layer 2. You can imagine what it could be. It's like your y hat values. All right. Now here you can apply to write your code. Yeah, as I told, we are working on what? Classification. So I need to put what? C point. So your layer 2 also worked out. So of course, yeah, I forgot to put a comma here. I need to use comma. All right. And then what's next? So here, anyway, my y hat values will be created at here, but I need to, yeah, I need to convert. I mean, I need to compare with what? This one. So layers dot dense. Okay. So you need to produce it to how many number of columns? With a single column only. Finally, you need to produce into one single column. So this 90 should become 90 columns should become what? One column. Sorry, 9. Yeah, one column. Okay, and so no need to work on because you are already applied your activation function in the previous set only. So here I will directly write as name equal to layer 3. That is your output layer. Exactly, this is your output layer. This is input layer. This is your hidden layer, and this is your output. Yeah, comma. Comma to be given or not at the end. Logically, it should be not there. Okay, we'll see. We'll put and we'll work on it. So your model is ready. Right now, let's write. Yes, model is ready with you. It is successfully compiled now without errors. Yeah. So what next? Your architecture is ready. In fact, now I need to compile this thing. Compile your Keras model. All right. So on this, like now, till now, what? How did we write here? In your machine learning, how you will actually write from scikit-learn dot linear underscore model? We will import your package name, and from there you will fit that. Right now, linear regression fit of dot fit of x comma y. This is how you used to write. So here a little bit change. The fit will be done in the next step. So still here I need to write what actually that you are trying to do, what you are trying to compare here. Okay. So model again. So you are adding some more flavor. Okay. For your why? For the same model name, you are adding some more flavor for the same model architecture. Okay. Some compile. And yeah, so what actually you are asking to compare here? Yeah, I'm asking to compare my results with the loss function. So which kind of which categorical function is required here? I mean, what you are actually comparing? My target variable is what? Classification. So what is the loss function for classification? Log loss. Right now, log loss is actually target variable classification. I mean, when a target is classification, you need to verify with log loss. So this one, log loss will be two types again. If you go back in my notes, I could have mentioned it somewhere back. Yeah. If I'm working on target variable, two outputs, binary cross entropy. Second one was categorical cross entropy. I mentioned two types. So do I need to use this one or this one? Binary. Why? Because we have only two outputs. So here binary underscore cross entropy. Okay. Yeah. That is one thing. And second thing is optimizer. So optimizer here I will write as Adam optimizer. So what is this Adam optimizer? I did not speak about much thing it was. If you try to recollect in your gradient descent, okay, try to recollect in your gradient descent the classes. At the end, when I'm explaining this presentation, you could have seen this one in your PDF. I think I have shared this PDF long back. Check out. There are a lot of optimizers functions will be there. So if you see here, yeah, let's recall it a little bit. Remember anything this one? Types of gradient descent. Batch gradient descent, stochastic gradient descent, mini batch gradient descent. Depends upon the size of the complexity of the data, we will use this any one of the type of gradient descent. Today we are going to use this one. Okay, and here three different ways of pulling the data into your this one and passing it and running it. Okay, and here if you go here, yes, I have taken this notes from here, this learning. Yeah, here if you see here, yeah, for choosing your learning rate, yes, now I am also able to recollect. I also forgotten, so I wanted to open this PDF to make recollect what it is actually outcome optimizer. Now I am able to recollect. Correct. So yes, your learning rate is to choose your learning rate value. Yeah, we are choosing Adam optimizer, Adagrad, RMS prop. So we have different methods of choosing your learning rate. Now hope if you remember what is learning rate, then it will be easy. If you not remember, then go and learn again gradient descent. Okay. I hope you are already taken, listen the video class again to recollect it is exactly what is the gradient descent. Okay. Because when you recollect gradient descent, you can understand what is learning rate. Learning rate is what actually it is trying to cut down your values into a small, from high jump to low jump. Anyone remember or forgotten? Big learning rate will take bigger values in change. Small learning rate will take smaller changes. So what changes it is? Coefficients, na? Coefficients to take a small size value and we'll look for the best value. So learning rate will help us to take the small, what do you say, this one, baby steps, baby steps it will call. Okay. So here learning rate selection will be taken care by your Adam optimizer. Right? That is what the thing it is mentioned here. Okay. Now go back. So that is what here I'm selecting as Adam optimizer. You can try with the remaining things as well. And what metrics? Just a minute. Yeah, what metrics? Metrics is, yeah, you are looking for, of course, one thing is binary cross entropy that you are looking for. Anyway, same way, I'm also looking for accuracy. How many codes are given here? ACCURS. Oh, so is not confused. Yeah, this should be fine. This should be fine. Okay. Now let's run it. So it is also successfully made run. Second, guys, this makes really sometimes boring. This GoToMeeting will keep on, half of the screen will be, it will be occupied. When I'm trying to look for your chatting window, it will drop down this GoToMeeting totally, and this will be covered up my total console window. If I try to make it up, I could not able to see your chatting window. You people will be asking, commenting, I don't see. It won't come by default. When I make it drop down, it is covering my console window, and I am not able to see my line is working or it is somewhere stuck out. That is the issue with this. People have used Zoom, then it will be works better actually. Zoom is good one. I did not see any errors with the Zoom. This GoToMeet have some technical issues. I mean, in displaying the things, in managing the things. All right, so let's come back. So this is what your things are completely ready. Like this is what actually now. Just imagine that you are writing import metrics from scikit-learn.metrics. Yeah, what you are trying to compare that. I mean, like you are comparing with your accuracy score and your log loss you are pulling from scikit-learn metrics. That line is similar to this. Now we are going to fit everything with the model. Okay, with one or two lines, everything will write everything. Okay, so here you need to understand a few things. Before going for the next line, I would like to explain a few things. One is, okay, what is epoch? One is not epoch, batch. I think I told about this batch in the gradient descent concept, but let me repeat it again. Okay, and other one is what, iterations. Okay, so you need to be clear on these three things first. When I will call as epoch, when I will call as iterations, when I will call as this one. Okay, just a minute. So here I have taken a small example row, so it won't be impact in your working data, working concept. But when you have working with the largest data, so you will face some issues. I mean, if I pass like 10 lakhs of rows at a time, okay, into your machine, your system will be hanged out in general. If I pass my 10 lakhs of 1 crore rows of data set into your machine, definitely your system will be hanged out. That is the problem. So what we have to do is we need to pass your data into some batches wise kind of thing. Okay. For example, if we have 2000 samples, or let's say 2 lakh samples, whichever. Okay. Let's take easiest way with the 2000 samples. That means what? 2000 samples, rows. I'm not talking about the number of columns here for time being. Okay, I'm talking about the total big set sample. So how it will be split up? So if I run up this total 2000 samples at one time, then it becomes what? One epoch. If I run up my total 2000 samples for one time, then it becomes what? One epoch. But actually, my one epoch, to run this one epoch, it will take a larger amount of time. Why? Because in real time, it will be not 2000 actually. It will be like 10 lakhs or 1 crore, 10 lakhs in generally. Understanding? So it will be 10 lakhs or 1 crores of rows, 10 millions kind of. Okay. So it will be very large. So can I run this total large number of data as one epoch? I cannot make run. So what I have to do is I will divide this 2000 sample into some batches. Okay. So I will take as, let's imagine that 4 batches. Now tell me, for each batch, how many samples will come now? Fine. Right now, for each batch, 500 rows will be 500 samples will be common. So that means what? To complete this entire task, okay. So I need to run 4 batches, and these 4 batches will run complete one iteration. Sorry, these 4 iterations. Okay. So each batch will contain 500 samples. Okay. Each batch contains 500 samples. So, and this will be what, like randomly, not like any order wise. Randomly, it will take 500 samples and it will complete one iteration. So, like that, how many iterations should required here? Iterations, TIO, yes. Okay. So, one iteration. So, how many iterations? 4 iterations are required. If I completed 4 iterations, that means what? I completed one successful, one successful epoch. Clear? If I completed 4 iterations, which is divided into 4 batches, okay? So this makes what? I successful one completed epoch. All right. So like that. So here also I need to divide. So this is like what case actually, if I strictly speak, we have learned this kind of theory long back. This is not new actually. Understand, this is not new. So if I run, 1 second guys. Yeah. If I so what is it? One epoch contains this 4 what is it? 4 batches will successfully complete their task. One epoch contains these 4 iterations will completely successfully complete their task. Like that, if I run for 100 epochs, so how much time it will take? So this is like, what do you kind of concept that you, if you try to recall, what kind of concept it is? Can anyone tell? We have learned this one long back. It's not new. If you try to recollect, this is all nothing new. Epoch, iterations, batches. We have learned this kind of words, not words, kind of methodology that we have run. What technique? Yes, resampling. Not regularization, resampling. Agree? We have worked on cross validation. So these are things are same. Resampling, that means what? See, what I said, 100 epochs. So this the same 2000 samples will be keep on publishing the results for 100 times with a different batches, because every epoch you will create a 4 different batches. Agree? Every epoch you will create a 4 different batches, so you will get some result. Like that, if you are making 100 epochs, that means what? 100 different results. That is what you learned resampling also. Resampling is what? The same thing, but here the people given a different name. When it comes to the deep learning world, people are categorized their samples collecting and splitting the data, okay, and randomly picking, and they used some other English words. That's it. But the kind of concept when it is working, when we are running, that is almost the same. So simply, what is epoch? A resampling method. Statistically, we are talking as a resampling method. Deep learning, they will call it as an epoch, iterations, batches. So generally, when I apply cross validation, and if I put some 10 times, what happens? Go for k-fold. What k-fold will do? I used to use k is equal to 5. So 5 different possible sets from the same set of data. No? 5 different possible sets, and we are trying to take one set as the test data, remaining 4 sets as training set. So much of learning that we had done. I don't know you remember or forget. Right now, from the last 6 months, how many concepts that we are learning, right? Try to recollect it. The same story here also. All right, come back. So here also we are writing the same thing here. So how we are writing? Model.compile, this is ready, and yes, fit the model. Model, same how you write fit, na? The same fit between what and what? Excel and Y. Agree? So directly I am writing here our epoch. So how many times that you want to rerun it? Epoch equal for 100 times. You can put 1 lakh. Okay. And for epoch, batch size. So actually we have here how many samples? We have 208 samples. Huh? So what I'll do, for every batch, last 10 samples only should come out. For every batch, you should take 10 samples. Okay. And it should and it should run the results. Like that, I am asking if this should be repeated for what? 100 times. For every batch, it will take only 10 samples and it will publish the results. It will take if you are calculating the mean square error, it will take the mean square error. If you are calculating the binary cross entropy, so you are calculating what? Log loss. All right. Like that, this will be running for 100 times. That means you are going to get what? 100 results. Okay. Let's run it. Unrecognized word. I know somewhere I will do mistake. Spelling mistake. Huh? E-P-O-C-H. Yes, epochs. Epochs should be there. Okay. Again, there is this. What I did here? Okay. Yes, look out here. For the first epoch, yeah. So what you are seeing here? Look out. Loss is reducing and the accuracy is stopped at 53. Look out here. So here, if you see here, what has happened? Yeah, epoch 1, what is the result? What is your error? What is your accuracy? For epoch 2, what is your error? What is your accuracy? For epoch 3, what is your error? What is your accuracy? So it is getting as now same value, but actually it should be improved. Okay, what we'll do, we'll run it again. We made a number of times rerun, somewhere it is collapsed. Let's rerun it again. So it should improve. My loss will be keeps on reduced for every epoch, and my accuracy will keeps on improve the performance. That is what should happen actually. Let's run it again. Yeah, it is improved. See, the previous iteration I made somewhere mistake. Understood, guys? I observed the loss, how much it is dropped to 0.0050. Accuracy got to 100. If you go for the first time, I mean the first line, if you see, for the first time, my accuracy is 53% only. My error is 0.73, our log loss. So for the second iteration, so this is what you are making a resampling thing, and you are changing the data, okay, and you are calculating everything like this. So this is what average accuracy of your first epoch, average accuracy of second epoch, average accuracy of third epoch. So what it is doing actually, this epoch will, if you go back, try to recollect what you learned in your past class. Oh, where is your lecture? Where is your flow? Where is your time? This one. Okay. Yeah. So how many times you have mentioned here? 1,000 times. So in this 1,000 times, what it is doing, it is keeps on changing the values. Like that, for every epoch, just keep on changing your values and it is improving the performance. Like that, your error gone down, your accuracy is improved. So and the error is keep. So if you see actually, yeah, after some iterations, the value is, yeah, I think here 0.5 to 47, again 57, it is improved there. Again drop, again improved. So where should I make cutoff here? That I need to realize. Maybe 96th iteration or 96th epoch, it is making much sense. After that, it is playing like ups and down, ups and down. So you are making some more fitting kind of thing. More fitting kind of thing. So you have to realize that, yeah, at what sample, I mean, now 100 is okay, but if you make 1,000 iterations, then it won't be much useful. Your error will be like 0.5, 0.4, 0.5, 0.4. So after that, it won't be goes for exactly 0. So you need to understand that where I need to stop these iterations as well. That is also be more important for you. Clear, guys? How we should run? That's it. Your simple linear, sorry, not simple linear. Simple neural network is done. Simple neural network is done. Simple. That's it. I share this code and example. Try it from your end. Okay. So yes, I think I am done. So let's meet up again in tomorrow's class with the next topic. In the same neural deep learning, we'll go for the next one. All right. Okay then. So let's log out. Any questions from anyone? Just listen this video again. You'll get clear if any. I mean, if you are anywhere missing something. I could say one or two people are logging out, logging in because of network issues. I guess. Just listen this thing. All right. Okay then. So let's meet up tomorrow. Bye bye, guys.